All right. Hello, folks. So what I'm going to do is I'm going to make a video going over this math diagnostic that you guys should take. Remember, the purpose of this is to show you how to do a lot of things that you're going to need to know how to do throughout the semester. So you should have already done this on your own first. If you haven't done that, I recommend you stop, go do the best you can, and then you can see what you really need to focus on. Then you can see what you need to get help with as we go further into the year. All right, so the first thing I want to talk about is scientific notation. Now, in physics, we're going to see scientific notation occasionally. Usually, students know how to do this, but you just need a reminder. So, scientific notation and engineering notation are different, but they're both the same thing. So, if you look down here with the E's, that's how you know you're dealing with an engineering notation. So engineering notation has the E's, and then scientific notation is always going to follow the format of having some number, okay, with the decimal listed immediately after the number, and then as many numbers as necessary after the decimal. And it's always going to have times 10 to the something, times 10 to the something. And so if we're doing times 10 to a positive number, okay, so if there's a positive exponent on the times 10 portion, that means this is a very large number. It's a very large value. If we end up having a negative exponent, that means we're dealing with a very small value, a very small number. And so we've got a couple of each down below. So here we go. Let's look at part number A first. Letter A. Haha. Okay, so 1.45 times 10 to the 8th. 1.45 times 10 to the 8th. So because we see a positive 8 here, we know this is going to be a big number. Now, the thing is, depending on what type of calculator you're using, you could actually type that into your calculator, hit enter, and it'll give you what the number actually is. But I would rather you knew how to actually do it. So think about this. If we're making a big number, we want that decimal to move to the right. Okay, so we want that decimal to move to the right. If it's a small number, like I'm going to skip ahead and look at B over here for a moment, we want that decimal to move to the left, because the further to the left that the decimal is going to move, the smaller the number becomes. All right, so let's look at A first. Well, how many places do we move the decimal? Well, that's where the exponent comes in. If it says times 10 to the 8th, that means I'm going to move that decimal 1, 2, 3, 4, 5, 6, 7, and 8. I'm going to move the decimal over to the right. Maybe it'll be more helpful. Let me rewrite that value. So we have 1.45, right? But I'm moving that decimal over 8 places. Now, because we can't just leave a decimal hovering in the air like that, we're going to fill in these empty spaces with zeros. And so what this number actually represents, and I'm going to rewrite it over here, is, let's see, I have 145, and then let's see, 6 zeros. And if we add some commas, we'll see that this is actually 145 million. That's it. That's how you do it. You look at the exponent. If it's a very large number, in fact, I'm going to write this up here, and perhaps you need to write it as well. If it's a large number, we're going to move decimal to the right, okay? And if it's a very small number, as we're going to see here in a moment, we're going to move the decimal to the left, okay? So if it's a small number, we're going to move the decimal to the left. So let's look at B. So this one says times 10 to the negative 9th. So this time I'm going to move the decimal 9 places. That's why the 9 is important. I'm going to move it 9 places, but I'm going to move it to the left. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And again, if it helps you to rewrite it, you can until you get the hang of it. But we're just going to write it down here. So 6.67. Once again, I move 1, 2, 3, 4, 5, 6, 7, 8, 9. So I get 1, let's see. And I'm filling them with zeros again. We can't just leave that decimal hanging there. So we're going to fill in with zeros. So what this number actually represents, and as you can see, that's a very small number. What this number actually represents is 0.0000000000667. And that's why scientific notation is really helpful. Instead of writing out all this junk every single time, because that's a pain, That's why we prefer scientific notation. Scientific notation is a lot easier to type into a calculator. It prevents you from making mistakes. All right, let's move on and look at C now. Okay, let's look at C. All right, so it's a big number, all right? We see that positive 9. So because it's positive, remember, we want this number to get larger. So I'm going to move the decimal to the right 9 places. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, you don't have to, but if it helps you to rewrite it, go ahead and do that. Because now we can see, okay, the decimal's not going to be right there anymore. It's going to be way down here. So I'll put that decimal right there, down there at the very end. And if we want to rewrite it, let's see how many zeros do we have. We have 7 zeros this time. Yep. And so this number actually is 8 billion. 8,990,000,000, and then some other zeros. But that's how you do it. Okay, let's keep going. Let's look at D. D's really easy. We're only moving the decimal to the right 2 times. I know I'm moving it to the right because it's a positive 2 instead of a negative 2. So I'm going to go, okay, 1, 2. So instead of 3.87, this is simply 387. That's it. That's it. Okay. If you want to think deeper about what these numbers actually mean, like what's the math behind it, I mean, think about this. What's 10 squared, guys? If you think about 10 squared, 10 times 10, doesn't that just give you 100? And so in reality, what you're doing is you're doing 3.87 times 100. So yeah, of course it's going to give you 387. Okay, but moving the decimal is how I do it. So now we get down here to engineering notation. So in E and F, these are both engineering notation. Understand this. Don't be scared of the E. The E is the same thing as saying times 10 to the something. That's really what the E represents. So if you want to write that down, if you're copying notes, and maybe writing this on your paper, that's what I would do. So the E, and understand, if you're using a graphing calculator, you actually have 2 of these E's on your calculator. There's a large E that's accessed by using the alpha button on your calculator, and then there's a smaller capital E that's just above the numbers, okay? So on my calculator, okay, I use one of these, but it's right there. Okay, so it's above the numbers, and you access it by using the second command. All right, so you hit the second button. So that's all E means. So again, if I see a positive number like I do in E, E to the positive 3 just means, yeah, I'm going to make it a bigger number. I'm going to move the decimal to the right, 1, 2, 3. I'm moving it 3 because of the 3 that's right there, okay? In fact, I mean, if it helps you, you could rewrite it. You could say, oh, so this is really 1.25 times 10 to the third. That's really what it represents. But then we're going to move that decimal 3 places to the right, okay? And so that's what we end up doing. All right, I got to get a move on. I need to hurry. Okay, so this ends up becoming, let's see, I'm going to rewrite it right here. 1, 2, 3. I got to add 1 0. So we get 1,250. That's really all it is. We only had to add 1 0 because there was 1 empty space, and so that's what we did. As we look at F, we see this is a negative 5, and so as I go here, I'm going to go 1, 2, 3, 4, 5 to the left. And so that means I'm adding, look, 1, 2, 3, 4 zeros, and then the decimal is going to go right there. Okay, so this is 0.1234 zeros. Mr. Aaron, why aren't you adding 5 zeros? I mean, look, I didn't need to add 5 zeros. There were only 4 empty spaces. So here we go, 4, 2, 3. So there you go. That's it. All right. So now, moving right along, it says for the following, write these in scientific notation. So remember, in order to attain scientific notation, I need to get it so that there's just a single number, look right here, a single number in front of the decimal, and that's it, okay? So I want to have a single value in front of the decimal place. So what that means then is like, let's look at G right here. I want to move that decimal so that it's right here. I want to move that decimal so it's right here behind the 4. So I want to be able to write 4.62 times 10 to the something. We don't know what it is yet. That's what I'm trying to do. But how do we find that? Well, you count. Look, 1, 2, 3, 4, 5. In order to put that decimal where I want it to be, moving the decimal this way, okay, we see that we had to move it 5 places. And so now you have to say, all right, well, is it going to be positive or negative? Well, remember what I told you. If you have a positive exponent, that means it's a very big number. If you have a negative exponent, it means it's a very small number. I mean, look at that. That's obviously a very small number. So this is going to be 10 to the negative 5. Okay, this is 10 to the negative 5. That looks like a 6. Let me redo that. 10 to the negative 5. Okay, so there we go. That's how you do that one. Let's look at H. So for H, once again, I want to move the decimal so it's right there. I want it to have a single non-zero digit in front of the decimal, and that's what I'll have. So I'm looking for something that looks like this, 3.25 times 10 to the something. Okay, I know that's what I want. Now remember, even though we can't see it, we know there's a decimal right there. You just never write it. I mean, it would be silly to write 325,000 and then put a decimal on the end, but we know that's where it is. So I'm going to move it to the left this time. 1, 2, 3, 4, 5. So I'm still moving 5 places, but in this case, it's going to be a positive 5. 325,000, that's a big number. And so that's why it's going to be times 10 to the positive 5. All right, as we go to I, once again, our decimal place is right here, okay? And I want to move it right here. I want it to be right after the 6, okay? Just to follow the format. So I'm going to go and say, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get 10. And so look, it's going to be 6.0, okay? And 6.0, that's good enough. It looks weird if you just do 6, but we'll call it 6.0 times 10 to the, what did I say, 10? Oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And it's going to be to the positive 10 because once again, 60, what is that, 60 billion? That's a pretty big number. So that's why it's going to be positive. Then we get to J. And this one's pretty close, but it's not quite there. I do need to move that decimal. So this right here. So this one's going to become 1.25 times 10 to the negative 1. Kind of weird, but that's what it is. We only had to move the decimal place 1 position. Okay. All right, next thing we got to focus on. Let's talk about algebra. Very important part of any math-based science class. Students must be able to rearrange equations to isolate particular variables. So all I mean is, like, look at A right there. I want to rearrange that equation to get B by itself. So isolating a variable means getting a variable by itself, okay? So we need to be able to solve for specific things within a formula using algebra. So for each of the following, it's telling me what we're looking for, and so that's what we're going to do. So let's look at A. So I have this equation, A equals B over C, and I'm trying to solve for B. So I want to get B by itself. That's the goal here, okay? And it's pretty easy. I mean, think about it. The only thing that's over there on the side with B that it's sharing that side with is C. So what I need to do is I need to get C out of the way. And so as you hopefully know, in order to get rid of something, you have to do the opposite. So in this situation, I want to get rid of C. I am dividing B by C. So if I'm doing division, the way that I get rid of C is through multiplication. So look, if I multiply by C, that's going to cancel it out. And so, hey, C's taken care of. But I know, hopefully you guys know this, whatever you do to one side, you have to do the other side. And so I'm not just going to multiply C over there, I'm also going to multiply it by the other side as well. So what we end up getting is we get B equals C times A, and that's it. That's all we're looking for. We got B by itself. That's it. Let's look at B. B is a little bit trickier, okay? So we have the same equation, but this time we're trying to solve for C. Now, I'm going to show you the easiest way. Technically, there's another way to do it. If you're interested, feel free to ask me in person. I'm sure we'll run into it again later in the year. But the easiest way to do it is I don't like solving for something that's in the denominator. So C is in the denominator right now, and that's not good. That's going to cause problems. So in fact, what I actually want to do is similar to what I just did in part A. Let me start by multiplying C out of that denominator. And again, I'm not just doing it on the right side. I want to do it to both sides. And there's a reason for that. I don't like dealing with fractions if I don't have to. So you might be saying, well, Naren, that didn't improve anything. You haven't gotten C by itself. Why wouldn't you just divide out B? Just trust me. Weird stuff starts to happen. But now I have C times A equals B, same as what I had in the previous problem. But remember, I'm trying to get C by itself. I'm trying to isolate C. And so, again, right now we have C times A. So if I want to get rid of A, just divide by it. So if I want to get rid of A, I'll just divide by it. And see, that'll cancel A. And whatever you do to one side, you have to do the other side. So what I end up getting is C equals B over A. And that's all there is to it. I'll put a star next to B. For whatever reason, that is the hardest algebra that students seem to have in this class. It's really not that bad, but it's something that a lot of students have difficulty with. Let's look at C. All right, so we have Q equals M times CP times delta T. Now, don't be confused. This delta symbol, which is represented by a triangle, that's just one variable, okay? In fact, if you want to think about it, this is basically like saying A equals B times C times D. That's really what we're looking for. It's just that in physics and chemistry, sometimes we call it CP. Sometimes we call it delta T, but it still just represents a single variable. All right, so I'm trying to get CP by itself. All right, say no more. It's not that hard. So I'm multiplying by M here. Remember, I'm trying to get CP by itself. So instead of multiplying by M, I'll divide by M. See? That's gone. And hey, while I'm at it, I'm multiplying by delta T. Why not go ahead and divide by delta T? And I'll go ahead and do it over there as well. You can do two things at the same time if you're careful and you're neat and you're keeping track of your work. Just be careful. And so this is what we get. So in this case, delta T and M are being multiplied in the denominator, and they're both underneath Q. But that's it. Look, I got CP by itself. Now's as good a time as any to remind you guys that if you're watching this, maybe down the road, maybe I told you, to watch this video to get some extra help, or maybe you're watching it in the class right now and I'm going too fast. I'll post this on Google Classroom. So if I'm going too quickly and you needed help with a particular section, I'd go back and watch it later. All right, let's look at D. I'll check my recording and make sure we're good. Yeah, I need to hurry up though. All right, so we have delta X equals VI times T plus 1/2 times AT squared. All right, a lot of junk going on. Technically, I have two independent terms over on this side. So I have V times T, that's one term, and then I have 1/2 AT squared, that's another term. And the reason I call them terms is because the first thing I need to do is subtract away one of those. Now remember, I'm trying to get A by itself. I'm trying to get A by itself. So in fact, the first thing I want to do, I'm going to subtract this. I can do that. Because those are together, because that's a product, because they're being multiplied together, I can just subtract that over to the other side, and that's legal. Because you've got to think, it's being added to everything else on that side, right? Term A, if you want to call it term A and term B, term A is being added to term B. So the opposite of adding is subtracting. So I can get that over to the other side. So I'll subtract over VI times T, like so. And as usual, when I do algebra, I like to rewrite what I'm dealing with. So that I keep my work neat, but also so that I know what I'm dealing with. So I'm going to go ahead and rewrite it. So hey, it looks kind of messy, but that's okay. We're getting pretty close. So now I need to get A by itself. So hey, instead of multiplying by 1/2, why not divide by 1/2? I can do that. So see, if I divide by 1/2, that cancels that. I need to divide this side by 1/2 as well. And yes, I know that some of you right now are probably saying, well, Mr. Aaron, dividing by 1/2 is the same thing as multiplying by 2. Yeah, sure, you can do that. Okay, so think about it, people. If you wanted to come over here and just do 2 times all this junk, yeah, you can do that too. It's the same thing as dividing by 1/2. I'm just going to keep it like this for now. I can rewrite, or similar to the last problem, why not just go ahead and divide over t squared? I want to get rid of t squared too. It's being multiplied by a right now. So look, if I divide by t squared, put it over here, ta-da, it's done. Now it's going to be tempting for you guys to look at that and say, oh, well, Mr. Aaron, if you've got a t on the top and a t squared on the bottom, can't you do some simplifying? You could, but it's more difficult than that. I would say just stop there and call it good. Okay, so I would stop here because look, we've done it. Acceleration is equal to delta x minus vi times t all over 1/2 t squared. The other way you could write it, if you did the times 2 method, right? It would just look like this. But they're the same thing. I promise, they're the same thing. So if you got either one of those, good job, you did it. And I got to tell you, those of you that are watching this right now and maybe starting to panic, don't panic. You're going to get lots of practice with algebra. This is just introducing you to it so you know what to expect. And I got to tell you, probably B and D over here on this side, those are the 2 hardest. That's as hard as it gets. B and D over here, oh no. All right, B and D over here on the right side, that's as complicated as it gets. All right, order of operations, rolling right along. Knowing how to calculate complex mathematical operations is important. It is critical you understand the order of operations. All right, I can stop right here. I don't know if you learned it as please excuse my dear Aunt Sally, or if you learned it as just PEMDAS, okay? And again, if you're a note taker and you're writing this down with me, now would be a good time to maybe write this down if you have forgotten it. If you know it, you're good. But PEMDAS, it's going to write it eventually after it's done thinking about it. But please excuse my dear Aunt Sally means that you always do parentheses first, whatever is in parentheses. Then you do the oops, I wrote an E twice. Let me redo that. Then you write the exponent. Then you multiply. Then you divide. Then you add. And then you subtract. So that's all PEMDAS means. All right, so let's look at A together. Okay, so Q is equal to 50 grams times 0.46 joules per gram degree Celsius times 145 minus 80. Okay, so this is interesting. So technically you would say, oh, well, don't we just go ahead and multiply everything? Don't we need to, because they're all in parentheses, can't we just multiply them all? But in fact, this operation, this whole thing, 145 minus 80, is within the parentheses. So in fact, the first thing I want to do is deal with that. So I want to do that first, 145 minus 80. So here I go, if my calculator has battery. It does, yay. So I'm doing 145 minus 80, and I get 65, all right? So I just did this little section right here, and I got 65. And at this point, look, now we're just multiplying. Now I'm doing 0.46, and by the way, that's degrees Celsius if you care. Now I'm doing just everything times everything. So now you can just go in and do your multiplication, okay? Because you've done all the parentheses. So now I can just do 50 times 0.46, one note's being a little slow, times 65. And then I end up getting my answer. Because now it's just multiply, multiply, multiply. And so I end up getting 149.5. If you're interested in canceling units, that's not really what I'm going over right now. But if you look, the grams are going to end up canceling. The degrees Celsius are going to end up canceling. The only thing that doesn't is this capital J. And so that's what your units end up being. Okay, so there we go. Done with A after it's done writing. Eventually. Okay, I'm going to move on to B while it's thinking about it. Okay, so on B, all right. So we've got a lot of parentheses on top. We've got a lot of parentheses on bottom. This is pretty common. This is something you can expect to see. What we want to do here, basically, is let's do everything on top first and do everything on bottom, and then we'll do our division. So I'm going to do everything on top, then I'm going to do everything on the bottom, okay? So I'm multiplying, right? Everything on the numerator, in the numerator is being multiplied. So I'm just going to do, and by the way, that's what that means. Whenever you see parentheses that are bumping up against one another, and I know some of you maybe forgot that, that just means multiplication. So I'm doing 2.5 times 5 times 300. In the denominator, same thing, 275 times 2. That's really what I'm doing here, okay? So here we go. All right, so I'm going to do 2.5 times 5 times 300. I'm doing it all in one go on the calculator. And so in my numerator, I get 3750. And technically the units are this mess. Okay, there we go. So that's what I end up getting. In the denominator, I'm doing 275 times 2, right? And so I get 550. I maybe didn't need to type that in the calculator, but that's okay. So I get 550 K times L. And so see, at this point, think about what we did. We did parentheses first because we had all those parentheses in the denominator and numerator. We don't have any exponents. We did our multiplication. Now we're dividing. So we did our multiplication first, and now we're dividing. So literally in the calculator, I'm just going to do 3750 divided by 550, and I get 6.82. I get 6.82. 6.82 what? Well, let's look at the units if you're interested. We got liters on top, liters on bottom, those cancel. We have Kelvin on top, Kelvin on bottom, those cancel. And as you can see, ATM is the only thing that didn't get canceled. And so that's what our answer is going to be. All right, let's look at C real quick. C, we have delta X equals 25 times 5. Okay, 25 times 5. Plus 1/2 times negative. That's a negative. That's important. Negative 9.81 times 5 squared. Okay, so exponents. That's pretty high up in the order of operations, but first we actually have parentheses. So the first thing I'm going to do is 25 times 5. Parentheses is going to happen first. So I'm going to do 25 times 5. I get 125. And technically it's, let's see, meters now, because the seconds cancel if you're interested. Okay, so I have 125. Great. The next thing I want to do is I actually want to do this exponent next. I have 5 squared down there at the very end. Obviously, you guys know 5 squared, 5 times 5 is just going to be 25. Technically, the units are going to become seconds squared now. So that square gets passed on to the seconds unit, okay? And so now what we have, looking down here at the end, is I have 1/2 times negative 9.81 times 25. And so, yeah, I can just go ahead and multiply everything out. We're not doing addition or subtraction yet. If we look back at the order of operations, we see that adding, that's pretty close to the end. So let's go ahead and multiply all this stuff out first. Okay, so here we go. I'm going to multiply all this stuff out. So in my calculator, I'm doing 0.5. Remember? 0.5, 1/2, same thing. 0.5 times negative 9.81. Make sure you hit that negative button on your calculator. Times 25. And I end up getting negative 122.625. The units are going to be meters. Okay. And so look, all we have left now, I'm going to rewrite it, I guess up above, is we have 125 meters minus, because of that negative, minus 122.625 meters. And that's all that's left. And so if you do that, I get 247.6. I tell you what, I'm just going to call it, I'm just going to call it 247.6. That's good enough. Units or meters, we're done. Okay, and again, I might be going a little fast for you guys. Remember, you can watch this as many times as you want, whenever you want. Really slow down and work on it. Being able to interpret graphs is a very important skill in physics. You must be able to determine a variety of things mathematically and then understand what it means in a physical sense. So what that means is instead of just x and y, in physics, you need to know, what does that graph actually mean? What's going on in the real world, all right? So it says for the graph above, determine the slope. Well, it sure would be nice if we had some numbers on here. So I can do that really quick. So we have 0, 0, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5. That's good enough. Remember, guys, when we determine slope, there is one equation that I hope you know, and it's just rise over run. Rise over run. Now, if you want to be fancy, I know that some of you fancy math people are probably going to say, well, technically, the rise is the change in the y. The run is the change in the x. So delta y over delta x. Yeah, that's what you're doing. But rise over run is just so much easier. So let's see if we have any intersect points. And it seems to me like we definitely have some intersection going on right there. I don't have a perfect grid on there, so that's about as good as I can do. So if I'm doing rise over run, this is what I'm looking for, guys. My rise, okay? Let's say I'm going to start right here, and I'm going to end right there where I just made that data point, okay? So there we go. You just pick 2 points. You can pick any 2 points, but typically you want to pick some where they line up with the grid lines, okay? So my rise, well, let's see. What was my rise? Looks like I went up +1, right? Rise was +1, not +2. Because remember, I didn't start at 0. I started at 1 on the y-axis. So technically it's +1 as my rise. So I can come in here and say, all right, so it's 1. That's my rise. Over my run. Well, what was my run? Look, 2, right? 0, 1, 2. So my run was +2. So I'll go down here and put that as my run. So what's my slope? 1/2 or 0.5, whatever you want to call it. I prefer decimals in this class, but hey, that's it. That's the slope. For the graph above, determine the y-intercept. I mean, remember, guys, y-intercept is the point where it crosses the y-axis. So basically, what is the value of y at x equals 0? That's really what it is. That's what the y-intercept is. And so if we look at my graph up above, okay, everywhere on this line is where x is equal to 0. Everywhere on this line. There you go. And so we can see that it crosses the axis right here at 1. So the y-intercept in this case is 1, +1, but still 1. Okay, and then when it says for the graph above, write the slope-intercept form linear equation. Guys, the linear equation is one of those things you need to know. Y equals mx plus b. Okay, y equals mx plus b. Y, okay, y is just y, so I'll just rewrite that. Instead of m, hopefully you know that m is the slope, and we just found the slope. We said the slope was 0.5, so I can say, all right, so this is 0.5 is my slope, times x. X is just x, so I'll just rewrite x. It's the x variable, plus b. And what is b? B is the y-intercept. And I hope this is ringing some bells. The hope is that I'm not just teaching you all this stuff. I'm hoping that I'm just reminding you of all this stuff. So my y-intercept in this case is going to be 1. So there you go. That's the slope-intercept linear equation for this graph. All right, let's keep looking. Actually, nope, that's it for graphs for right now. Let's move on. Right angle trig. All right, we're moving. In this course, you must be able to analyze right triangles quickly and be able to solve for any part of these triangles. So I might ask you to solve for one side of a triangle. I might ask you to solve for the hypotenuse. I might solve for an angle, whatever. You will not need to know law of sines or law of cosines. That's not something that you need to know. I know that some of you know it, but I'm not interested. What you do need to know is sine, cosine, and tangent. Okay, and I'll talk about Pythagorean theorem here in a moment. In fact, tell you what, I'm not going to get ahead of myself. It's going to answer those questions for me. So let's just keep going. What is Pythagorean theorem equation? It's pretty easy. A squared plus b squared equals c squared. I'm really hoping that you guys know that. A squared plus b squared equals c squared. And then I said label the triangle above, okay, to reflect this equation. All right. So A and B are sides. So see, there's A, here's B, here's C. C is the hypotenuse. Always, always, always. Okay. So we have AB and we have C. It'll load here in a minute. All right. So it said label the triangle above. I've done it on my end. It's just taking it a second to sync up and load. But yeah, the hypotenuse over here is C. There you go. See, what did I tell you? Which side of the Pythagorean theorem is this set up to solve for? Technically, it's not set up to solve for anything. Because the thing is, this isn't going to help you solve for the hypotenuse. The way that this is written is going to help you solve for the hypotenuse squared, right? So technically, none. Technically none. But think about this. If we want to get rid of that square, all right, we don't want to solve for c squared. We want to solve for c. So if you wanted to solve for the hypotenuse, right, you just need to square root both sides. And look, if we square root this, that cancels the square, right? It'll show up here in a second. But we also have to square root the other side as well. And so technically what I'm trying to get you guys to see is that if you want to solve for the hypotenuse, technically this is what you want. Technically, that's what you want. Okay? All right. Next, it says rearrange Pythagorean theorem to solve for the b side. All right, so we're going to solve for side b. I'm just going to rewrite it again. A squared plus b squared equals c squared. Okay. I want to get rid of a squared. Remember, we're trying to isolate a variable. We're trying to get b by itself. So let me go ahead and subtract a squared from both sides. Like that. And so now what we have, I'm going to rewrite it over here, is b squared equals c squared minus a squared. But we're not done. Remember, if I were to stop right here, that's not giving me the length of side b. No. That's giving me b squared. So all that's left to do is if I square root both sides, remember, whatever you do to one side, you have to do to both sides. That'll cancel the square, and that'll fix it. So technically then what we have is we have b is equal to c squared minus a squared square rooted. Ooh, that was a really ugly square root. Hold on, I'm going to rewrite that. There we go. And that'll come through in a moment. There you go. There you go. List the three main trigonometric functions below. So I don't know how you guys learned them. Maybe you learned them as some old hippie. Fill in the blanks. SOHCAHTOA is how I learned it. Or maybe you just memorized them. But the three main trig functions are like this. Sine of theta equals opposite over adjacent. Opposite over hypotenuse. That's so, okay? So this is opposite over hypotenuse. Next we have ca. So that's cosine of theta equals adjacent over hypotenuse. So that's ca. And then you also have TOA. So that's tan of theta is equal to opposite over adjacent, excuse me. So ca TOA, however you want to remember it. Add additional labels to the triangle above to reflect these functions. Okay, so I need to add, instead of doing ABC like I did with this, I need to label them as opposite, hypotenuse, and all that stuff, okay? So in order to do that, though, we have to have an angle. So I'm just going to decide this is where my angle is. That could change from problem to problem. Maybe you'll have an angle up here. But the issue is, whenever you're doing trig functions, you need to have one angle that you're basing them all off of. So we know hypotenuse is hypotenuse. Okay, in fact, I'm going to change the colors. We know that this is the hypotenuse over here, the C side. It's the long side. But how do you know what's opposite and what's adjacent? Well, look, if you look opposite the angle, see, I'm drawing a dotted line out from the angle, directly across from it, directly opposite it is the opposite side. And so therefore, the adjacent side is the one that's next to the angle. So there you go. That's all there is to it. Okay, check, I did it. What's next? Rearrange each of them to solve for the angle theta. Okay, pardon. Excuse me. All right, to solve for theta, all of these equations up above can be rearranged. I just have them memorized, but you have to use what's called the inverse function of each of these. And if you look on your calculator right now, you'll see that by hitting the second button and then tapping a sine function or a cosine function, whatever, gives you the inverse. And so I'm just going to give them to you. But this is how you solve for theta. So if you needed to find what is the angle, I know opposite and hypotenuse, what is the angle? This is what you do. And I don't have time in this class to go into why this is. If you're really, really interested, you can go ask a math teacher. But what you do need to know is how to use them. So understand, I'm just kind of spitting them at you right now. I'm just giving them to you. I'm saying, look, all we've done is flip-flopped, right? We've flip-flopped the theta and the fraction on the right side. We flip-flopped them, but when we do, that's why we use inverse trig functions. All right, we're wrapping up. Okay? Again, that's it. If you want to write these down in your notes somewhere, that might be a good idea. Okay, and again, you have this piece of paper. Just don't lose this piece of paper. Okay, determine the values of the other two sides of the triangle above. Okay, so see, in this situation, we're looking for, see, watch, I can follow out from the angle. I'm looking for the opposite side, and I'm also looking for the adjacent side. So I'm looking for the other two sides of the triangle. Okay, now, they've given me the hypotenuse. So at this point, this is when I would look back over my equations and I would say, all right, which equation is going to help me here? And sine comes to mind for this side. So if I'm looking for the opposite side, sine of theta, remember, is equal to opposite over hypotenuse. And that's really helpful because think about it. I have the hypotenuse, right? I have the hypotenuse and I'm looking for opposite. So that's perfect. So in order to get opposite by itself, remember, now we're just doing algebra. In order to get the opposite side by itself, instead of dividing by hypotenuse, look, I can just multiply hypotenuse to the other side. See? So let's see what we actually have now. Now what we have is the opposite side is equal to hypotenuse times sine of theta. And we can just plug in some numbers. So my hypotenuse for this problem is 40 meters per second times sine of theta. Theta in this case is 30 degrees. By the way, in this class, make sure your calculator is in degrees. Check to make sure your calculator is in degrees. I'm checking mine right now. Yeah, no, see, I'm in radians. I'm glad I checked. See, so I'm in degrees now. So I'm doing 40 times sine of 30, and I get 20. There you go. I get 20. Technically, it'd be 20 meters per second if you care, but there you go. So that's that side. And again, if you guys are watching this and you're thinking, wait, how did you know to use sine? Look at what I had. I was looking for opposite. I had the hypotenuse. That's why I picked sine. I had theta, right? 30 degrees is theta. That's why I picked sine. But now, as I look at the adjacent side, When I look at the adjacent side, I'm going to use cosine. Here's why. Look at the formula for cosine. Okay, it's adjacent over hypotenuse. So cosine theta is equal to adjacent over hypotenuse. And if I'm looking for adjacent, hey, that's really helpful. So look here. I'm going to multiply hypotenuse to the other side because I want to get adjacent by itself, just like I did in the previous problem. So instead of dividing by hypotenuse, multiplying it will help me cancel it on that side. So what I end up getting is adjacent is equal to the hypotenuse times cosine of theta. See, I'm in business. I know the hypotenuse is the same, it's still 40 meters per second. I know theta is still 30 degrees. My calculator's in degrees. So in my calculator, I'm going to do 40 times cosine of 30 this time. Okay. And I get 34.6. So there you go. Now, technically, some of you may be watching this, and by the way, it'll load what I wrote here, and there it goes. Some of you may be watching this and saying, but Mr. Narian, once you have 2 out of 3 sides, couldn't you just use Pythagorean theorem? Because as long as you got 2 out of 3 sides, you can use Pythagorean theorem. You can. For me, it's just easier to use sine and cosine. All right, last thing. Sorry to go kind of fast, but again, you can pause this. You can pause and ponder in your own time. Let's keep going. Determine the value of theta on the triangle above. All right, let's see what we got. We got 3 different equations, in case you've forgotten, that are set up to solve for theta. See, theta is already by itself. Theta is already by itself. Theta is already by itself. We just need to figure out which one to use. So as I look at this triangle, okay, I can follow out from theta and see, okay, this is the opposite side because it's across from theta. So 100 meters is the opposite side. And then 135 is adjacent because it's right next to theta. So I've got opposite and adjacent. So if you look back at your list, you'll see this is the equation. We want to use tangent. Not just any tangent, we want to use the inverse tangent. This negative symbol right here that I'm drawing an arrow to is very important. There is a difference between simple on tangent and inverse tangent. So make sure you click inverse tangent. Okay, so now I can just plug in the values. Oops, I erased too much. Go away. All right, so now I can just plug in some values. So I'm doing inverse tan of opposite, which was 100 meters, over adjacent, which was 135 meters. And this is going to give me theta. So I'm going to make sure to hit the second key, then tangent, to get inverse. Okay, I don't know if you guys can even see this at home, but see, make sure you're looking at the right function. Okay, and then I'm going to do a 100 divided by 135 in the parentheses, and I get 36.5. And it's degrees because my calculator's in degrees. All right, I got to wrap this up quickly. I'd like to remind you that this is stuff you need to know how to do. If you are having difficulty with this stuff, do not wait until the test on this material, which will be down the road. I'll be honest, we're going to kind of put math on the back burner. I'm telling you all this stuff now so that you know what the expectation is, and now you have a point of reference so that when we start getting into this stuff, you can come back and watch this video. You can look back at some of these samples that we just did, but this is stuff that you need to know. So I hope that was helpful. If you have questions, you can always contact me at my email here. I'll write it up here at the top. Then you guys will have it. Okay, so if you want to set up time to talk with me before or after school, if you have questions, that's how you can contact me. Thank you very much for your time.